Diễn ra từ ngày 8 tháng 5 đến ngày 10 tháng 5 tại Trung tâm Triển lãm và Hội chợ Sài Gòn SECC, quận 7, thành phố Hồ Chí Minh. 3 triển lãm công nghệ quy mô quốc tế là triển lãm về phát thanh truyền hình và thiết bị nghe nhìn tại Việt Nam, triển lãm về thiết bị chụp hình và công nghệ hình ảnh Việt Nam, triển lãm về công nghệ LED, OLED với sự góp mặt của các doanh nghiệp đến từ hơn 30 quốc gia và vùng lãnh thổ, đang thu hút được đông đảo sự quan tâm của khách hàng tham quan. Đây là lần đầu tiên ở Việt Nam có 3 triển lãm quy mô lớn được tổ chức chung với nhau ở một không gian rộng 8.800 m2. Triển lãm lần này có sự góp mặt của các ông lớn trong làng công nghệ như Canon, Sony, Panasonic, HTC, Oppo. Tham dự triển lãm, khách tham quan được dịp chiêm ngưỡng và dùng thử các sản phẩm mới nhất, hiện đại nhất. Từ những máy quay phim 4K 3D cao cấp của Sony, người tham quan còn được tiếp cận với các phụ kiện quay phim, chụp ảnh cao cấp đến từ các công ty nước ngoài và hòa mình trong không gian của các phòng chiếu phim, giải trí gia đình. Tại triển lãm lần này, các hãng điện thoại lớn cũng mang đến những smartphone chụp ảnh đẹp nhất của họ, đồng thời cũng tổ chức các workshop để hướng dẫn mọi người những cách cơ bản để có một bức ảnh đẹp. Ngoài ra, chương trình còn nhận được sự quan tâm của các câu lạc bộ đến từ các trường đại học Hoa Sen, RMIT, các diễn đàn như VN Photo, Teen Photo, Yêu nhiếp ảnh và nhiều cộng đồng chuyên môn khác. Triển lãm là cơ hội để khách tham quan có thể thỏa sức trải nghiệm vô số sản phẩm công nghệ mới nhất và đa dạng.
The recent updates to Apple's popular MacBook Air line are minor, but welcome. It's hard to complain about more processing power for less money, right? No doubt, some will be disappointed that the new MacBook Air doesn't have any of the features that have been running through the rumor mill. It doesn't have a Retina display, it's not a 12-inch laptop tablet hybrid, it's not thinner or lighter, and it doesn't ditch the trackpad for optical touch sensors. In fact, from the outside, the new MacBook Air is exactly like the older model, except for maybe the amount of angle the screen can open to. See, that looks a little different, doesn't it? The major change is inside, where you'll now find a 1.4 GHz Core i5 Haswell processor. Our benchmarks show some slower performance in storage-related tests, but a marginal boost in application performance over the previous 1.3 GHz processor. The other major change? Apple reduced the price by $100. The new MacBook Air may not have much in terms of new features, but if your laptop is several years old, now's a good time to upgrade.
Researchers from Japan's University of Electrocommunications have created a way for blind people to feel what's on smartphone and computer displays. Called Hamsa Touch, the project converts images from a screen into electrical impulses you can feel on your hand.
It uses a smartphone as a camera and the electrotactile display to present the tactile image. As a result, you can feel the surrounding scenery with your hand.
On the device is 512 photosensors, which map to 512 electrodes. In this demonstration, the device is placed directly on top of a screen, and as a line passes under the device, the electrodes are activated, and you can feel a slight tingle of electricity under your hand. In another demonstration using a smartphone camera, the images are first converted to line drawings. The Hamsa Touch is placed over the smartphone screen, which converts the line drawings into electrical impulses. The device is powered by a rechargeable battery and can output a maximum of 1 watt. Users can control the impulses using a knob on the device. The highest level feels more like an unpleasant shock than electrotactile feedback, but the system works effectively at lower levels. Whether or not the project will help people with visual impairments remains to be seen.
Perhaps our next very important step is for a user study with very blind people, and we determine which steps we should go.
In Toronto, Nick Barber, IDG News Service.
AMD has unveiled a bold new plan to bridge the worlds of x86 and ARM through a development effort called Project Skybridge. AMD has been making ARM processors for servers for a couple of years, but with Project Skybridge, it will start developing ARM chips for client and embedded devices too. And it plans to use a new design that will allow it to build x86 and ARM chips that are pin compatible. That means a PC maker could swap out an x86 chip for an ARM chip without having to redesign the whole product.
Project Skybridge is really the very first time that you will be able to see x86 and ARM SoCs that are put together in such a way that they can be pin compatible. So you can have a motherboard that runs ARM, you can have a motherboard that runs x86.
AMD also announced that it's developing its first ARM chips that run Android, a popular operating system for tablets. It's a long-term effort, however, and the first Project Skybridge chips aren't expected until next year. System builders will be able to combine them with AMD's GPUs and other components to speed up graphics and other programs. AMD hopes Skybridge will make its chips more attractive to device makers. Among other things, it says, they'll be able to make last-minute decisions about whether to use x86 or ARM chips without incurring a lot of extra cost. The Sunnyvale, California-based company continued to push ahead with ARM server chips too. At an event in San Francisco on Monday, it gave the first public demonstration of a 64-bit ARM server processor called Seattle, running the LAMP software stack, the WordPress blogging platform, and serving video. AMD is relying on ARM to help it regain server market share. In the first quarter, its share of the server market was just 2.8%. That's down from 4.7% a year earlier, according to Mercury Research. Intel had a 97.2% market share in the first quarter. CEO Rory Reid said Project Skybridge continues a transformation strategy that AMD embarked on 3 years ago.
Where that next generation cores are going to go, it's world-class next generation graphics and a sister set of cores, both clean sheet, bottoms up, both ARM and x86, introduced to create true leadership in a market opportunity that's much broader than we've ever had before.
In San Francisco, Melissa Aparicio, IDG News Service.
If we compute like the brain, then we can develop technology that has the power of the brain. And so that allows us to develop a robot that uses much less power for its computation. You can develop much more autonomous robots, and your robots won't always be tethered to some large power supply.
NeuroGrid is a system that can simulate 1 million neurons in real time. And that kind of power, which is teraflops of computing power, is only available in supercomputers. And these supercomputers burn on the order of about 1 million watts. This is just to simulate 1 million neurons. Your brain has 100 billion. And the brain is using about 20 watts. What we've done is we've taken the same transistors. Instead of using them as digital logic, right, we use them as actually analog circuits. And we try to design a circuit such that the level of voltage corresponds to the level of voltage inside a cell. The level of current corresponds to the amount of synaptic input. So when you're done with all this, you've saved a lot of power.
So this is the NeuroGrid board. So you get 16 chips laid out in a tree network to give you 1 million neurons. The software is not restricted to being used as a simulation tool. So it's a wide spectrum of audience. Neuroscientists who are interested in simulating and understanding the brain, or engineers who are interested in using spiking neurons to do interesting applications.
This becomes potentially clinically viable for, say, quadriplegics or people who have lost control over some limb for some reason or another. You can bypass wherever that damage is by taking signals directly from the cortex and then control some kind of robotic limb. The low power aspect is required for the clinical viability because it needs to be low power in order to be implantable. NeuroGrid and the neuromorphic technology enables that.
That's the promise of this kind of technology. That's the kind of inspiration that we get from the brain.
You need an inverter before. Exactly. I can get